Interference. So interference means the phenomena of superposition of two coherent waves in the region of superposition. So we have to consider a medium. So this medium consists of the bright spot and also the dark spot. So if the bright light or bright spot called as maximum intensity, or it is again also called as constructive interference. So if the intensity is minimum in this medium, so that is the less intensity at that place, so that point called as destructive interference phenomena taking place. So if the lambda is the wavelength of interfering waves and del as the phase difference at a point, then the condition is so if the maximum of condition phase difference del equal to 2m pi or path difference delta equal to m lambda, so where m equal to 0 1 2 etc. So similarly for condition of minima, phase difference equal to 2m plus 1 pi, path difference delta equal to 2m plus 1 lambda by 2. So where m equal to 0 1 2 3 etc. The relation between the path and the phase difference is phase difference equal to 2 pi by lambda into path difference. That is, the phase difference is the multiplication of 2 pi by lambda into the path difference. So for this interference phenomena, so we have to consider an example of interference in thin films. So or the film of oil floating over the water, or thin film, that is soap film on the water. So we have to consider any example. So this is the thin film. So when the light is incident on source on the thin film from source A to B, and in this place there is an refraction or transmission and reflection also takes place. So the light will reflect to C and transmit to D, the point D, again in this D point, so it will reflect to E point and transmit to the I point. So we have to, so this is the incident angle I, this is refraction angle R, and this difference between the thin film to G point 2t, and this is the thickness of the film T. So here we are considering the refractive index. So refractive index N. So this is the air medium. So we have to draw the vertical line BM to the DE and also EN to the BC. So this is the explanation for the diagram. So we are considering the path difference between the two reflected rays, N equal to BD into DE minus BN. So N into BD plus DE can be written as DM plus ME minus BN. So we know the value of N equal to sin I by sin R. So in this diagram, so in this triangle, so sin I equal to BN by BE. So BN by BE and sin R value. So in this sin R equivalent to ME by BE. So ME by BE. So here sin I equal to BN by BE. So in this angle sin R equal to ME by BM. So sin I equal to, so here BE cancelled each other, so remaining BN by ME. So from this find BN equal to N into ME. So path difference N equal to, so that is equation 1. So from this equation path difference equal to N into BD plus DM plus ME minus, instead of BN, so substitute NME. So N into BD plus DM plus NME. So multiply N into ME minus NME. So this both plus NME minus NME cancelled each other. So N into BD plus DM. So BD can be written as, so here BD can be written as GD, that is BD is equal to GD. So here instead of BD we can write GD plus DM. So n into GD plus DM, GD plus DM, that is equivalent to GM, the whole length GM. So n into GM. So in the triangle BGM, BGM, find cos R equal to GM by BG. GM by BG value is 2t, BG value 2t. So substitute GM by BG 2t. So from this find GM equal to 2t into cos R. So then from equation 3, path difference equal to n into GM. So n into GM, instead of GM write 2t cos R. So this equation can be modified as 2nt cos R. Then the reflected ray BC suffer a path difference of lambda by 2 on reflection at B. Then the net path difference between BC and EF can be written as 2nt cos R minus lambda by 2. So if the film appears bright, the condition is 2nt cos R minus lambda by 2 equal to m lambda. So multiply 2nt cos R minus into minus lambda by 2. So if it goes to that side, plus lambda by 2. So 2nt cos R, so lambda by 2, so just take it outside the lambda by 2, remaining 2m plus 1. So m equal to 0, 1, 2, 3, etc. If the film appears dark, the condition is 2m plus 1 into lambda by 2. So 2nt cos R, so minus lambda by 2, so it will goes that side plus lambda by 2. So lambda by 2 common to both terms, so take it outside, lambda by 2, here 2m plus 1, here lambda by 2 is in the outside, so remaining 1. So lambda by 2 into 2m plus 1 plus 1, 2. So again 2 is common, so take it outside, lambda by 2 into 2, here remaining m plus 1. So here left side 2nt cos R equal to m plus 1 into lambda. So this 2 and 2 cancelled each other. So here m is an integer, n plus 1 also integer. So finally 2nt cos R equal to m lambda. So m equal to 0, 1, 2, 3, etc.